9.6 Properties of Logarithms. We're going to take a look at three of the major ones: product property, quotient property, and power property. And let's start with the product. It says log of xy base b is equal to log of x base b plus log of y base b. Now, to prove this, what we're going to do is we are going to set each of these two equal to different variables. So let's say this is equal to m, this is equal to n. And what we're going to do is we're going to change these into exponential functions, or equations. So b to the m now equals x, and b to the n now equals y. Now let's just say that we do x times y. Well, x times y is really b to the m times b to the n. And based on what we've talked about on exponents before, what we do is if we have the same base of exponents, we add the exponents together and we can merge them. So that becomes b to the n m plus n power, which is equivalent to x times y. Now, if we rewrite it in logarithmic form, it's log base b of xy equals m plus n. We then know, based on our substitution, log base b of xy equals, and we go back and we substitute m for log base b of x, and we substitute n in for log base b of y. And that kind of shows you how we kind of prove that product property. And then very similar to that, the quotient property has that same sort of principle. But instead of doing multiplication, what ends up happening is that if you have a subtraction sign between the logs that have the same base, you're going to end up doing division. And finally, the power property. Let's just use numbers for a second with this one. Let's say that I had log base 2 of 5 to the third. That's really equivalent to log base 2 of 5 times 5 times 5. Now, based on that product property, that would be log base 2 of 5 plus log base 2 of 5 plus log base 2 of 5, which is really 3 times log base 2 of 5. So what happens here is that exponent gets pulled to the outside. And you can see that kind of in that basic definition right here of if you have that exponent on that argument, it becomes a coefficient of that log. What we're going to do for this, the first few, is we're going to write these logarithms as a single logarithm. So, and we're going to use those properties just to do that. So if I have log base 7 of 40 minus log base 7 of 8, because the base is the same, that's important to check out first, and because it's subtraction, we're going to use the quotient property. So this is going to become log base 7 of 40 over 8. And then from there I would simplify. Log base 7 of 5. Go ahead, pause the video, and see if you can do the next three. With number 2, we have the same base, but because it is addition, we're going to use the product property. So we're going to have log base 2 of 7 times 5, which will be log base 2 of 35. For number 3, again, that base is the same. It's a base of 3. So we're going to do log base 3, and because it's addition, we're going to multiply. This time though it uses variables. So we're going to do x times the quantity x minus 9. What will happen is we'll just go ahead and we'll distribute that. And so you will get log base 3 of x squared minus 9x. Number 4, it's going to be that quotient property. I'm going to do log base 3. And I'm going to keep this as a fraction because you'll notice that nothing's going to reduce or cancel out. So it's x cubed plus 4 over x squared plus 2. In 5 and 6, we're just going to use the power property to rewrite these logarithms. And remember that the power property says that the exponent can kind of come out in front as a coefficient. So we're going to have the 5 pull out, so it's going to be 5 times log base 5 of x. And number 6 looks a little bit trickier, but if we recall what radicals kind of simplify to or change to, it shouldn't be that difficult. We have log base 7 of cube root of 4. Well, this is really log base 7 of 4 to the 1/3 power. So hopefully you remember that we can write radicals as exponents. So with that 1/3 now, I'm going to bring that to the outside, so it's 1/3 times log base 7 of 4. And to finish up this video, we're going to take a look at writing these as single logarithms, but just with multi-steps. Why don't you pause the video and see if you can figure out these 3, and then check your answers at the end. In number 7, what you'll notice is this is going to use the product and quotient property. They all 3 do have the same base, which works out well for us. There's a plus sign which indicates product, and then the minus which indicates quotient. So what we have is we have log base 11, and then we're going to do 8 times 3, and then we're going to divide it by 2. And then we just kind of use order of operations and evaluate. 8 times 3 is 24, divided by 2 is 12. For number 8, it does use the product, or the power rule, because it has 5 on the outside. So what we're going to do is we're going to move that and change it to an exponent of that argument. And that minus sign again denotes quotient. They have the same base, so we're going to put it together, log base 2. And we're going to use that quotient property, and we're going to do 2x minus 1 to the 5th power over x to simplify that a little bit more. With number 9, we do have that power property again, so that 3 is going to go outside of that 2. And let's evaluate that right away. Log base 4, and then 2 to the 3rd is 8, so let's change that right away. And it also happens for the second term. And we move that to the outside of that 2. So it's going to be plus log base 4 of 25. From there, that's that product property. So we're going to get log base 4, 8 times 25, which evaluates to log base 4 of 100. Sorry, that should be 200.